Okay, so this is Phys 2320 Computing 2, and this video is going to be all about using and writing modules. So in the functions video, and in particular in function 1, we introduced the idea of abstraction in programming, which in computer science basically means dividing a problem up into easily sized, easily managed tasks that you can then go and run separately or develop separately or think about separately. So functions are basically the bottom unit of abstraction in an awful lot of programming languages, Python included. So they're the thing you work with most of the time. So the point of putting code into functions is partly to split up the problem and make it easy to go and test each individual part, but it's also to allow you to reuse code between two different programs, because often you're going to find there's some similar tasks. So for example, if you're reading a data file, if the format of the data file is the same, it doesn't matter how you're going to analyze the data afterwards, you still need to go and read the data file in from disk, and so it's sensible to have a function to do that, and it's sensible that you then use that function in lots of different programs rather than reinventing the wheel every single time. So the point of a module is it allows you to group together a whole bunch of functions together, and often that's functions that have some common purpose or are somehow related to each other. So one of the things you find if you look at big Python programs, in fact, is that nearly all of the actual program is a bunch of modules that are all attached together, and the main script of the program is something that's relatively short and simply just starts calling functions from the various modules that the author has written. So modules let you group everything together, and they also help you reuse functions because they provide a kind of convenient way of organizing the functions you've written previously. Okay, so as I was saying, modules are our next layer of abstraction. You've come across modules already, and modules that contain functions are things that are, for example, the system modules. So that's things like math and sys and OS. They're what's called the Python standard library, and you can find out all the functions and all of those modules by looking at the Python documentation. There also have modules that are written by you or by other programmers, and they are also things which contain functions. So when you're doing an import my module, what's actually going on under the hood is that if you haven't previously used my module, so if this is the first time you're importing it, then what Python does is it goes and finds the file that corresponds to my module. So that's probably mymodule.py. There are some other formats that are used for pre-compiled modules. They're mainly things in the standard library. So most of the time it's going to find mymodule.py and it's going to run it. And it's going to then remember all the functions and all the variables that were defined inside that module. If you then import the module again, then Python remembers it's already done the running it once and figuring out where it was, and so it doesn't rerun things a second time or a third time. It runs through it the first time, but after that, if you import it lots of times, it says, okay, now I know all about this. So what this means is that any program, any Python program you write, can be imported as a module, so long as its name ends up being a valid Python identifier. So that means it starts with a letter or an underscore, and it contains letters, underscores, and numbers. So most importantly, if your Python program has a space in its file name, you're not going to be able to use it as a module. But if you don't have a space in it, then you can import it. Okay, so here's a quick little sort of example of how things happen. So we have this file mycode.py, and it has a couple of functions and it is a variable. So if I do import my code, then what happens is it reads that, finds mycode.py, and it runs it. And in running mycode.py, it defines a couple of functions, and it defines a variable, and then it remembers what those all were. And it makes them available in your program as mycode dot, and then the name of the function or the name of the variable. So mycode.myfunc ends up calling myfunc from mycode.py. And likewise, you can print mycode.x, and it says, okay, go and get the value of the variable x that was defined when I ran that code. You've got other things you can do. You can import my code as stuff, for example. So that's now saying, find mycode.py, run it, but rather than presenting the functions, the variables back to the program that I was writing, my calling program, as my code dot whatever, it comes in as stuff dot whatever. Why might you want to go and do this? Well, sometimes you want to have something that's a little bit shorter to write than having to write the full name of the module. So we'll see this when we come to look at a lot of the NumPy and matplotlib modules, where there's also a convention that you import them with a different name. So you do an import NumPy as NP, for example, traditionally, and that just makes it a bit quicker to write the functions. It's good to follow these conventions if you know what they are, because it makes your code easier for somebody else to understand. And you want to go not crazy about it, because if you decide to, for example, to import NumPy as Z, then you're just going to confuse other people who are trying to read your code, and probably end up confusing yourself as well at some point. Anyway, if you do that, then those functions are available as stuff.myfunc and stuff.x and everything else. The other thing you can do, and this again is something you're going to end up doing quite a lot, is importing just one particular function into your calling program. So this is how you do it. You do from my code import, say, my other func. So what happens there is that Python is going to find mycode.py, it's going to run it just the same as we did for any other import, and it's going to run through it, and it's going to get all those definitions of the functions, and it's going to get the variable, but then it's only going to make my other func appear in the program. And the important thing is, if you do this, then my other func doesn't have anything. It's not my code dot my other func, it's not stuff dot my other func, it's just my other func. So if you import a single function in, you don't need to put the module name in front. And just for for completeness, you've also got an option to do from my code import my other func as thingy, and that's, as you could probably work out from the syntax, it's importing just my other func, but it's making it available in your calling program as thingy and not my other func. So you can just do thingy. Again, places where you might want to go and do that are if you want to go and shorten the name because you're going to use the function an awful lot. And sometimes it's useful because you can import a different way of doing the same sort of function, and if you rename it to have the same name as an existing function, then it'll overwrite the existing function. Of course, you can abuse this. So if you do something like from math import cos as len, then you've just stopped the len function from working because you've overwritten it with the cosine function from the math module. So that would clearly be a very stupid thing to go and do. So you need to be a bit careful. Okay, so let's just go and show you this working in Spider itself. So here I have a little bit of code called wizzy.py. It imports a module time. I've got a couple of functions defined. Let's just add a variable to that as well. What should we call it? Let's have boom equals hello. Okay, so I can run that. If I just run that, then you see it just runs. There's no code that produces any output, so it just sits there and runs, and that's fine. Okay, here I have another Python program. At the moment it's completely empty, and it's just called script. I'm going to start off by importing Wizzy. So now I can do Wizzy dot, and you see that Spider's being helpful for us. It's giving a list of the various things that we could be importing, and you'll see also it's given us a little icon at the start of the name that tells us what it is, whether it's a function, whether it's a variable, or whether it's a another module itself. So one of the interesting things you see here is that the names that I've got available inside Wizzy are all the things that would have been names inside when I ran Wizzy as a program. So I've got wizzy.time, which if one looks at the code you see it is in fact just where I've imported time into Wizzy. That's now made time a module inside Wizzy. So import Wizzy, let's have wham, which I remember rightly takes one argument. And we could have, let's just have a look at WYSI and see what that did. So wham just prints whatever I give it. We could have print WYSI dot boom and print WYSI dot bang. Okay, there we go. There's a very simple program, and we can run that. And yeah, you see the output. It's just run all of those things, and we can carry on and do whatever we like. We could of course also rename import WYSI as WH. Okay, you see now that Python is now saying, oh, we've got some problems. It's telling us we've not used the module WH, and is now telling us that we've got all these unknown WYSI for each functions. So obviously then you just have to change everything to match. And then it'll be happy. Okay, there is one thing. You remember that I said that if you import a module twice, it only actually does the running the code once, and this does give you a little bit of a problem. That if I now go back and start editing the WYSI module, then by default, if I just run my program again, it's not going to bother trying to look for WYSI.py and run through it, because it's going to say, no, I've already imported it once, because it goes with the Python interpreter, so it goes with the fact that the console is still there. There is a setting in Spider that stops it from doing this, so if you're actually writing modules yourself, then what I would do is I go to the preferences, and in, if I can remember where it is, it's not modules, sorry, no, I need to find the right part of the preferences, and find where I've put it. There is an option you can set to go and tell it to automatically unload the modules, and there it is. Is it? No, yes, no. There we go. I knew I'd find it eventually. It's an option, I have to say, that's moved between different versions of Spider. So if you're in Spider 2, then it's probably stuck somewhere in the console settings. If you're in Spider 3, then it's in the Python interpreter settings, and it's this user module reloader, which will automatically reload modules for you. If you don't have that on, then you need to tell Python to reload a module when you've edited it. You do that with a reload. So I could do reload WH, and that tells it to go and reload what I've just written here. So every time I edit WYSI, I'd need to reload it again. Okay, so that's as simple as things get for just writing your own bit of module. Okay, so we write our code as a module, but of course then you want to go and test your module by running it. But of course when you import things, you don't want to run the test code. So let's show you what happens. So here's our WYSI module, and let's just try and make sure we've got some tests in. Oops, so I can type. Okay, so there we go, that's our test code. I've even put a little comment there to remind us it's our test code. So if I run the WYSI module, then you see it executes its test code. Okay, no problem. The problem comes when I go and run the script code. So this is the thing that's doing the import. And you see what's happened here is it's going to run, as we've done the import, it's gone and done the test code before it started executing the code we want. But we don't really want that. We don't want our test code suddenly firing off when we're trying to use the module. So we have a way around that. So what we do is we put a little test in to say, is this code that we're running at the moment, are we running it as the main program, or are we just running it because we're importing it as a module? And this is how you do it. It's a little if statement, and we're testing this special variable. So in Python, if everything that's got a double underscore at the start and end of it generally means it's a special variable or a special function. So when you're running a program, then it creates a special variable called underscore underscore name underscore underscore and gives it the special value underscore underscore main underscore underscore, and that's set if you're like that, if you're running this as a program, as a standalone script. If you're importing it as a script, then the name is not set to be equal to underscore underscore main underscore underscore. So we can test that with the if statement and use that to protect our test code. So we just need to change our WYSI module like so. So notice that underscore underscore name underscore underscore is a variable, and the value it's being tested against is a string. So although the string looks like it's a Python special name, it's actually a string value you're testing for. Okay, so now if we run this module just as it is, then what's going to happen is we're going to run down to here, and it's going to say, oh yes, this is it is being run as a script, so we carry on and do these lines. And so you see it saying hello and giving the date. If, however, we run it from script, the import, so previously it did the initialization code, is that as part of the initialization did that test code. Now it just does the code we want. So we've stopped it from running the test code here by doing this test. And this is going to be something you're going to want to pay attention to, because for your final assessment, what you're asked to go and write is a Python module. You're going to be asked to write a Python module with a particular function in it, and then anything else you do is up to you. We'll cover all of that in the lecture towards the end of February, and in the task sheet for the final assessment, but for now this is just introducing you to this little bit of syntax. Okay, so that's fine. You can import a module. You might want to know what's in it. I've already shown you how Spider can help you in the editor. If you don't have that available, or you want to get a list of all the things that are available, then there's a special dir function. So I can come down here and I can do dir, whoops, get my brackets the right way round, dir wh. So wh is the identifier of the module when I imported it into the script. Whoops. And there you go. So now you have a list of the names that are available. So it's a Python list, and all the names that are available are come back as strings. So you can see down here the things you were expecting: the ban, the boom, the time, and the wham. And then you've also got some double underscore things. So you've got the double underscore name. We've already used that. That was the thing we were testing in the module to see what it was called. There's double underscore file, double underscore. So we can actually see what that's got in it. WH dot underscore underscore file underscore underscore. And what it tells you is the name of the file that the module is stored in. WH dot underscore underscore doc underscore underscore. gives you a string back, and you see that, if we look at the code, that's the doc string for this module. So you can find out about doc strings in the second video in finding and avoiding bugs in code. Okay, so dir is a useful thing for figuring out what's inside a module. So the other thing that we need to know is, how does Python actually know where to look for your module? So it's actually a relatively straightforward set of rules. It first of all looks for a built-in module, so something that's actually part of the core language. It then looks through a set of directories that are stored in what's called sys.path. So this is a list of directories that's available inside the sys module, and that contains the current scripts directory, then a list of directories that are given to it by the operating system. So all operating systems that you'll be using have what are called an environment variable. So in Windows, this is hidden away in the System Control Panel Advanced tab. In Macs and on Linux, it's part of the what you can get at with the terminal window. You can get this set of variables that store values. So one of the variables that you can set and store is called Python path, and it's a list of directories to go looking for bits of Python code. And then it also looks for a set of the standard library locations. So it says, I know my Python is installed in this directory, and therefore I expect to see Python modules installed in these other directories relative to where my Python executable is actually stored, where the Python is actually installed into. Okay, so we can go and have a look at sys.path. It's very easy. You just do import sys, and then you've got sys.path, and there we go. So this is on my Linux machine here. I get a list of directories. The first entry is just an empty string, which basically means the current directory that I'm working in, which is where my script would be installed from. And then there's a lot of directories that are related to where I've got Anaconda Python installed on my particular machine. I haven't got a Python path set on this machine. In Spider, you can actually manage your Python path. So there's a little Python path manager, and you can add directories. So you can actually manually set it in Python, and then in Spider, and then you need to restart your IPython console, which you can do simply just by closing it and reopening a new one. And occasionally it takes just a few minutes to do that. If you're on the cluster machines in the university, it probably takes quite a few minutes to go and do that, because they're a little bit slow. Okay, so that's how you can control where to load modules from. So for example, if you were doing a big program for your final year project, then you might well go and have a directory in your M drive where you keep all of your modules you've been working on, and then you could set your Python path to point to that, so that when you ran your program it would find all your modules for you. For this course you won't need to mess around with that. If you are writing modules on this course, you should just keep them in the same directory as your main code is sitting in. Okay, so in summary then, in this video, what we've covered is that any Python file that's name is usable as a variable, or could be an identifier, can be a module. You can import a module. When you import it for the first time, the code inside it is run, which means any testing code you put in your module you should protect by making sure that you're not running it when you're just importing it, and you use this if underscore underscore name underscore underscore is quotes underscore underscore main underscore underscore, then you can avoid your code from actually running, except when you're actually running your module as a script rather than importing it. I've shown you how you can use dir to tell you what is defined inside the module, and the other thing that we didn't actually mention but sort of follows is that any name that starts underscore is generally considered to be a private or internal function or variable, not something that you should be using by importing by the program, by the script that's doing the importing. This, I should say very clearly, this is a convention. It's not a rule. So this is kind of goes a bit to the philosophy of Python. Python is sometimes described as being for consenting adults. That means that when you write code, you can indicate to somebody who's using your code what they should be allowed to play with, but you can't go and stop them from messing around with other internal things. Likewise, if you're using somebody else's module, yes, you can use anything that's defined in the module, but if things are start with an underscore as a name, then you should probably expect that they may or may not do what you're expecting them to go and do. And if you change the version of the module you're working with, it may or may not do the same thing. So that's just kind of a convention there is. And then finally, I showed you sys.path as a list of places where Python looks for modules and how you can edit what's in there.